All right, I want to take a look at the problems that I think are going to be the hardest type, the issue that I think is going to be one of the hardest things in this unit. Okay, and I just wrote it up here so you could read through it again later. I'm just going to highlight certain things. The issue comes in when you're working problems out of 7-1 and 7-2. A lot of times you're going to be using the law of sines, and you're going to use it to figure out the measure of an angle. And if you use your calculator and you do sine inverse of a positive number that's less than 1, the calculator will give you back an angle that's in the first quadrant that has a sine equal to that number. Okay? All right. Now, the thing is, there is an angle. So like we're over here now. We had sine inverse of some number, and the calculator gave us back an angle, and they gave us back an angle that's in this quadrant right here, because that's what the calculator will do. Okay. The thing is, there may be an angle in the second quadrant. There is an angle in the second quadrant that would have that same sine value, because the reference angle for, say, that one I just drew in black, if that's the same, if this little area, this amount of rotation is the same as this, then that angle right there is going to have the same sine value. Okay. That doesn't look like it's the same. Let me make it a little bigger. So I'm trying to make it so it's the same rotation. So this angle in the first quadrant right here, okay, has the same sine as this angle in the second quadrant, because this angle and the reference angle of the one in the second quadrant are the same. Okay, and sine is the y coordinate, so sine would be the y coordinate, and see how these would both have the same positive y coordinate. Okay, and sometimes you need the angle over in the second quadrant. Your calculator is not going to give it to you. It's going to give you the angle in the first quadrant. So you have to reason out whether you need the angle in the first quadrant or the second quadrant. See, both of those, both are angles that could be angles in a triangle. They're less than 180, so they both could be answers to your question. Okay. So here's an example. So if you did the sine inverse of 0.3845, the calculator would give you 22.6 degrees about. Well, over in the second quadrant, you would have an angle that's 157.4 degrees. And see, that reference angle right there would have the same sine. Okay, you would have the same sine for 157.4 because the reference angle in the original and the 22.6 degree angle are the same. And see how both of these are up? So both would have a sine value that is positive. And you might need the 157.4. Sometimes you need to consider both 22.6 and 157.4. So that's the issue you need to kind of understand and think through in order to really do a good job on some of the questions that you see in 7-1 and 7-2. So I thought we'd look at 3 examples where this could be an issue. Okay, so here's one. All right, so we have A is 65. Okay, we have that little a is 13 and little b is 14. Okay, now looking at that, I can see that I have enough information to be able to use the law of sines. So that's what I would do. And I'm trying to find angle B. So when I set it up, I'm going to put angle B, the sine of angle B on top. Okay. Sine of 65 over 13. All right, so then I'm going to be solving that. So I'm going to come in here and multiply by 14, multiply over here by 14, okay? And when I do that, I wind up with sine B equaling, I'll say equaling about, because I'm going to have to round, I'm sure, equaling about 14, let's do that on the calculator, 14 times sine of 65 all divided by 13, and I get about, I'm going to keep about 4 decimal places that I write down. I'm actually keeping it all on my calculator screen. Okay. And so then I'd have to do sine inverse on both sides. Okay. And when I wind up doing sine inverse to get the value of the angle, okay, let me just write it that way. So when I do sine inverse to get the value of the angle, okay, here's where the calculator is going to wind up giving you an angle about 77. I'm going to go ahead and round to the nearest degree, 77 degrees. Okay. All right. And then I would just maybe go on and do the rest of the problem if I weren't careful. Okay. What you've got to worry about, and you should do it right now, is you have to ask yourself, wait a minute, what else could that angle really be? The calculator will give me back the 77. Then I need to think a little bit about this. Could there be another one? So I have to think about it. So here's the 77 degree angle that has a sine of 0.9760. You see over here in the second quadrant would be another angle that would have the same sine because its reference angle is also 77 degrees and it's up. So the value, it would be a positive sine value as well. So what you need to do is you need to take 180 minus 77. Okay, when you do that, you'll get 103 degrees. And you have to think about whether that's possible with the other information you have. Okay, so B could definitely be the 77 degree angle. So I know that. B right here could be the 77 degree angle. All right, what I just found out is that maybe it could be 103. And so to know if it really can be, you have to think about, well, I've already got an angle that's 65. If I take 103 and I add 65, I only get 168, and that's still less than 180. So that means it would also be a potential triangle. It is a triangle that I need to consider. So this is one of those cases where you're going to have to wind up solving 2 triangles. Okay. So the given information, of course, doesn't change, but you have to do the one where B was 77 and then do the one where B was about 103 degrees. Okay. And then you need to finish up the rest of the problem. Okay. The finishing up part is not what gets tricky. It's that consideration right there. Knowing that, so need to solve both triangles. Okay. And so you go ahead and set that up, and then you can find C, of course, by just subtracting from 180 and then using the law of sines again. Okay, so we would come in and would get that C would be 38 here. C would be 103 plus 65 minus 180 would be 12. Okay, so both of those are possible, and then you would just use law of sines to finish it up. Okay, so, but that's the hard part. Then you would just finish. Okay, by using the law of sines to get your little C. Okay. All right. So I want to show you what the issue is. The issue is that we drew the triangle and it kind of matches this picture with the 77 degrees right here. Okay. But if I took that 13, that side 13, and I just flipped it, it could have formed a triangle over here where I had a B over here. So sometimes what we do is we talk about this being B prime and this being C prime and this being little c prime. Like it's the second triangle, second option that you get. And see, then remember the 65, that was this angle here. Okay. And then what we found B prime was this B prime right here, okay, turned out to be 103 degrees, okay? And so you have an obtuse triangle, that's the blue one, but then you also have that original one here, that's this part, okay? And then this goes with the blue triangle, okay? So I'm not going to finish that, but I wanted to just explain what the issue is and how you have to do this analysis right here. You have to look to see if there could be a second triangle. Now, here's the issue. Say that you got that to be 77, okay? And you subtract 77 from 180 and you get the 103. So 103 would be the other angle that could have that same sign, okay? If the original angle A was, instead of being 65, what if A equaled like 92 or something like that? Well, then if you took 103 plus the 92, it would be more than 180, wouldn't it? And if it's more than 180, that's not possible in a triangle. So not possible. And you wouldn't have to deal with the 103. Okay, so that's the issue. Okay, all right. Now with these next two cases I'm doing, the issue is that if you will work these problems by trying to avoid that issue, it'll save you a lot. Okay, so if you have side, if you read through the steps on that summary sheet, one of the things it says is that the first thing you should do is get the angle opposite the longest side, okay? So the suggestion is for you to find this, okay? And this is a problem where you can't use the law of sines initially. You have to use the law of cosines. And so what they're saying is when you set it up, look for the longest side and make sure you get the angle opposite that, okay? The reason you should do that will become clear in a moment. So if I set up my law of sines, it would be a squared equals b squared plus c squared minus 2bc cosine of angle A, okay? So when I plug in the information I know, all I have is the A as my unknown. Be careful when you're solving this. There's lots of places where people make arithmetic mistakes. So 121 equals 81 plus 25. This is minus 90 cosine A. The 81 and the 25, that would be 106. But you can't put the 106 together with the minus 90. You shouldn't do that because the cosine A is multiplied by that 90. So from here, what you should be thinking is that you need to take away the 106. Okay. When you do that, you get 15 equals negative 90 cosine A. And then you should divide by the negative 90. And that's going to tell us that cosine A, and let me do that work. I'm going to take the 15 divided by the 90. It's going to tell me the cosine A is about a negative 0.1667, okay? Now, since we picked the biggest angle when we did the law of cosines, what it helps us avoid is ever having to worry about checking for a second angle. Because when you're doing the cosine, if you have something that has a negative value and you're doing cosine, your angle in a triangle can only be somewhere in here. If the cosine is negative, it is not here. So it must be here. And so it's going to return back to you, the calculator will return back to you the obtuse angle, okay? And so you do your cosine inverse, of the negative 0.1667, and you get, well, that turns out to be about 100 if you round to the nearest degree, about 100 degrees. And so because you already found then, when you go back up here, because you already found the obtuse angle, you know that these two right here must be acute. So you will not have to worry about checking the second angle, because to find the remaining angles, you're just going to use the law of sines at this point, okay? So for instance, to find angle B, you would do sine B over 9 equals sine of 100 over 11. And so sine B would equal 9 sine 100 over 11. And so the sine B turns out to be about 9 times sine 100 divided by 11, turns out to be 0.8058 for sine B. And so when you do the inverse sine to get the angle, okay, what you're going to get back is an acute angle, and it's going to give you back 53, 54 if I round to the nearest degree, about 54 degrees. But because I already have my obtuse angle, I don't have to worry about whether it's that or is it the one in the second quadrant. Okay, I don't have to worry about that. Okay, so if I forget to do it, I'll be okay. So that's why they have that suggestion when you're dealing with the side problems. If you will find the angle opposite the longest side first, then if it is going to be obtuse, you'll get it right there. So you will not have to worry about checking for that second angle. Okay. All right. And then here's another one where that can happen. Okay. It doesn't happen right off the bat though. So here's a situation where we can't use the law of sines because we don't have 3 parts out of 4 when we look at the missing pieces. Okay. So that means I'm going to use the law of cosines here. And the only thing I could do is find a, little a. So that's what I'm going to use it for. So I'm going to take my a squared. It should equal b squared plus c squared minus 2bc cosine angle A. Okay. And then I'm going to plug in all the information I know. So I know that b is 6, that c is 15, and that A is 22 degrees. Okay, so all of this just works like a dream. You just plug it in. You should work all that out on your calculator. Take the 6 squared plus the 15 squared. Go ahead and do minus 2 times 6 times 15 times cosine 22. Do make sure you're in degree mode. And you wind up with 94 point, I'm going to keep a little accuracy here since it's not my final answer yet, point like 107. And that's my a squared. And so I'm going to square root that now. And when I do, I get that a is about 9.7 if I round to the nearest tenth. Okay, so that 9.7 goes right there. Okay. All right, now, what can be an issue is this. Let's say that you wind up going in and looking for C next, okay? So let's say you just decide to set up the law of sines and find angle C, okay? So what you would do is you would do sine C over 15 equals the sine of 22 over 9.7, okay? And so the sine C should equal 15 sine of 22 over 9.7. Okay, so you're going to multiply 15 times the sine of 22, divide by 9.7, and I did something wrong, so let me try that again. 15 times sine of 22 divided by 9.7. And I get that sine of C should be about 0.5793. So I'm going to inverse sine, find out what that turns out to be, and it tells me C should be about 35 degrees if I round to the nearest degree. Okay, so you might go on and just put that in there and then go on and say, okay, 22 and 35. Let's see, B should be 180. B should equal 180 minus 35 minus the 22, and you'll get B to be about, okay, what would that be? 57, 180 minus 57. And so you'd wind up with B being about 123 degrees. You'd put that in there and think you're finished and move on. But that cannot be correct when you look, because do you see how C is the longest side? It should have the biggest angle. B is the shortest side. It should have the smallest angle. Okay? All right, so the directions you'll notice when they talk about the steps. See, the issue is that there's another angle that we could have considered for C, okay? 35 is here. There's another angle right there that would also have the same sign, and it would be 145 degrees. That's 180 minus 35. And so really, it's hard to know it at this point, but really I shouldn't have used the 35. I should have used the 145. See how hard that is? Okay, so if you want to avoid that issue, then here's the way you should approach that problem. You should follow their idea. Oops, let me not erase the whole thing because we could still do the first part. Okay, you could still do the first part. Okay, so do what you did right here. This is the only thing that would make sense to get A. So get your A. But then when you get over here on this part, don't find C next. Okay, what you should do is, instead of finding C, is you should use law of sines to find the angle. Find the angle. You write it better. Find the angle opposite the shortest side that is left. So between 6 and 15, I should use the 6. So if I set up my law of sines using B instead, then I would just type in 6 sine of 22 divided by the 9.7, and I would get that the sine of B should be about 0.2317. And then if I inverse sine 0.2317 and get my angle, I get that B is about 13 degrees. Okay, and so you might be thinking, yeah, but there's an angle over here, 180 minus 13, that could be the answer. Okay, you might be thinking that, but no, can't be this. Okay, B is the angle opposite the shortest side. It cannot be obtuse, so I don't have to consider the obtuse angle. I know this would have to be the 13, and then I would take the 22 plus the 13, get that, subtract it from 180, and I would get the 145 that way. And so I'd never have the issue of having to make that decision. Okay, I know this is complicated. That's why I wanted to show you 3 cases and kind of explain why they have that suggestion in the steps for when you do side angle side, that after you use law of cosines to find the one other side, then you should find the angle opposite the shortest side because you know it's acute. Okay, let me write that in a different color, because it must be acute. which would mean you don't have to worry about thinking about the obtuse angle, okay? And then back with the side, the recommendation there is to find the angle opposite the longest side first, okay? So that's what you're supposed to do, is find the angle opposite longest side first, because cosine will give you the obtuse angle if there is one. It's not a matter of it could be this or it could be that. And then if it is obtuse, then you've got the obtuse angle out of the way. And so when you go on and find the others, you really don't even have to check on that, because you know if there were an obtuse angle, it would have had to been here. So you know when you start using the law of sines, it can't be, the remaining angles can't be obtuse, okay? All right, and then with the side-side angle ambiguous case, occasionally you get, with these, you sometimes get only one triangle. Sometimes you get that no triangle is formed, but this is the example where you get two different triangles, and it's for that same reason, that there's an angle in the first quadrant and an angle in the second quadrant that would have the same sine, okay, sine value, and both of them could be angles in a triangle. Okay, this was kind of a long video, but I wanted to go ahead and do it all in one.